Okay, let's recap really quickly what we have discussed up to this point. We have used multiplying like bases where we add our exponents when our bases are the same. We have raised a power to a power where we were multiplying our exponents. And then we've also used product to a power where inside our parentheses we had a multiplication problem, and each one of those factors in that problem had to be raised to the exponent outside the parenthesis. So now we're going to take a couple of those concepts and apply them in division. Now we're going to look at first the key concept. We've got two of them for this video. We're going to focus on one here, and this one is dividing powers with the same base. So this is going to be similar to the multiplying powers with the same base, except this time we're dividing. And so if I were to ask you if we're adding exponents when multiplying like bases, then when we're dividing like bases, what are we going to do? And hopefully a lot of you all would figure out that we're going to subtract. So that's exactly what we're doing here. We have a to the m divided by a to the n, and you just simply subtract your exponents. So it's exactly like the multiplication where you write the base one time. So like this example, we have 2 to the 6th divided by 2 to the 2nd. So we write the base one time, our base is 2, and we simply subtract our exponents. So it's very, very easy. So 2 to the 4th. And like we've discussed, sometimes you'll see this left as 2 to the 4th, and sometimes they'll go ahead and simplify. If you notice in this problem here, we're subtracting x to the 4th divided by x to the 7th. When I subtract those, I actually wind up with a negative exponent. And we know that from the very first video, we can't have negative exponents. We need to go ahead and write that in a positive form, so that would be moving it to the bottom and making it a positive 3. And then this last example here is just showing you subtracting exponents when they are fractions. So let's apply this property to problem number 1. We have x to the 5 halves power divided by x squared. So our like base is x, and our exponents are 5 halves and 2. And so we're just going to simply subtract those. It's very easy. 5 over 2 minus 2, when you subtract that, you get 1/2. So x to the 1/2 power. So we are using the properties of dividing like bases. That means we must subtract our exponents. All right, so let's look at another one here. Now, the difference in this one and the last examples that we've looked at, this one actually has two different variables. We've got m and we have n. So what you could do is, let me use my cursor and just kind of cover up the n part here. Focus on one variable at a time. So if we look at our m's, we have m squared divided by m to the 5th. Okay, so those are like bases, so I would have to subtract 2 and 5. Okay, so if I cover up my m's, let's think about what are we going to have to do with our n's. Okay, n to the 4th divided by n to the 3rd. So like base is n, so I'm going to have to subtract 4 and 3. So this is what this is going to look like. They've set this up for you like base m and subtract 2 minus 5, and then like base of an n and subtract 4 minus 3. Now I can't do anything once I've done the subtraction here. We've got the red and the blue. I can't do anything with m and n together, okay, because they're not like bases. So don't try to add exponents up here. These are not like bases. But what I do have left over is this negative exponent that has to be moved. And so then what they did was moved it to the bottom of the fraction. So notice we were talking about moving boxes. Put a box around your m because that has to move. That means the n remains on the top and the m gets moved to the bottom so that it has a positive exponent. Okay, so just a little more complicated because there are two variables instead of just one, but break it down into each individual section to make it a lot easier. All right, so now it's your turn. This one's pretty simple. You've got like bases, you're dividing. So remember the division property, you subtract those exponents. Now here's your answer choices. Your correct answer And hopefully you pause the video and practice this problem. You're subtracting your exponents, so make sure that you have subtracted correctly, which your correct answer is y to the 1/4. And so this is just simply showing you how to do that. Subtract your exponents and you get 1/4. All right, so let's look at using this in scientific notation.
In this problem, you will divide numbers in scientific notation. Population density describes the number of people per unit area. During 1 year, the population of Angola was 1 in 2100ths times 10 to the 7th power people. The area of Angola is 4 in 8100ths times 10 to the 5th power square miles. What was the population density of Angola that year? What do you know? You know the population of Angola and its area. What do you need? You need to find the population density. What's your plan? Write the ratio of population to area and simplify. First, write the ratio of population to area. Subtract the exponents when dividing powers with the same base. Simplify the exponent. Now divide. Round to the nearest thousandth. Write the number in standard notation. The population density of Angola is about 25 and 2/10 people per square mile.
Okay, basically what he did in this last step here was he just took 0.252, okay, this number, times 10 to the second. And writing in scientific notation, we move the decimal point so that we have a number between 1 and 10. All he did was move it 2 places backwards, because the exponent of 2 there, to simplify it into standard notation, how you would typically see your numbers if they're not really, really small or really, really large. So he's just simplifying this into 25.2. And all you're doing is you're just trying to figure out the population density, about how many people live per square mile. We could do that in Franklin. We could find out what the population of Franklin is and how big Franklin is to figure out per square mile about how many people live there. So that's what this population density problem is.
Now it's your turn.
So let's take what you just did in that last example, and this is of Honduras. This is the population of Honduras, and it's a very large number. That's the reason why we write it in scientific notation. And then the area of Honduras is 4.33 times 10 to the 4th square miles. So this is how big it is. So write the population density, or what is the population density of Honduras for this year, or for this particular year. So exactly like the last problem, you set up population over area. And then you're going to simplify your like bases, divide the A's, those are the numbers here in front for scientific notation, and then simplify it. Now these are your answer choices. Obviously we're trying to figure out about how many people live per square mile. So think logically when you're trying to maybe eliminate multiple choice answers about what probably would not be correct, just to narrow things down for you. Pause the video though, make sure you give this problem a try, but the correct answer is B. 169.3 people per square mile. And so this is how they set it up. You divide population by the density, or by the area, excuse me, and then you're going to simplify your exponent, divide the a's there, and then just simplify further. Go ahead and multiply times 10 to the second to figure out about how many people there are per square mile. All right, now the next key concept that I want to go over quickly is raising a quotient to a power. And raising a quotient to a power is like raising a product to a power. It's a lot like distributive property. You have a quotient, which means you have a division problem inside the parentheses that you are raising to an exponent. So that simply just means that the a has to be raised to the nth power and the b has to be raised to the nth power. So it's kind of like our multiplication, our product to a power, where everything in there got the exponent. That's the same thing here. So 3 has to be cubed and 5 has to be cubed. So that's where this is simplified. And then they went ahead and cubed the 3 and the 5. Okay, and you can see that here, x and y both got the 5, a and b both got the exponent of the half. So you just simply like distributing the exponent to everything inside the parenthesis. So we look at this example here. We have z to the 2/3 power over 5. All of that is in parentheses raised to the third. So what that means, based on quotient to a power, is that z to the 2/3 must also be raised to the third, and 5 has to be raised to the third. So we've got our multiple choice answers there, but this is how you're going to simplify that. Z to the 2/3 to the third over 5 to the third. Everything in there gets raised to the third power. Then what you have in your numerator is power to a power. So this is bringing back something from a couple videos ago. Power to a power. So 2/3 times 3 gives you 2. And then you just simplify 5 to the third down to 125. So the correct answer is D, z squared divided by 125. So I want you to try a quotient to a power problem. This one you have 4 divided by x to the third, and all of that entire quotient is raised to the second power. So it's kind of like distributing. You want to distribute that exponent to each one of those pieces of the quotient. Now, here are some answer choices that you can pick from. It also just helps if you get an answer and it doesn't show up here. That means you need to go back and double check what you've done. All right, hopefully you have worked this problem out. The correct answer for this problem is C. Square 4. 4 has to get the exponent of 2, and x to the third has to be squared, which that will actually give you a power to a power whenever you square x to the third. So you have to multiply exponents when you have a power to a power.